All right, second half of the P&A session. We made a very simple and quick theoretical round on how to pull the casing. It's basically the same as what we saw with the tubing. You first punch a hole to circulate it clean, and maybe a lot of nasty stuff behind. You also log to see what is in behind, so that you know where to punch and where to cut and so on. You kind of make a road map as you go, but experience would tell you how things would be, so you have an indication in beforehand, and then you have like a cutting strategy. After a bit of struggle and a lot of effort, you would have something that looks like this. You have cut into the open hole and all the casing is gone. So very simplified step this. It pertains a lot of use of, for example, spare to pull the tubing. Casing hanger running tool needs to be in place, and to be able to pull, you have to remove the seals. You have to, on the casing hanger, you have to handle returns from behind there, so on and so forth. And also unscrewing old casing may be an issue in itself. It may be quite stuck after many years. Yeah, so we end up with a situation like we saw, and then what we do is to cement. And again, it's the balance plug method that is the preferred. So we make a plug that goes into the casing like this. That creates our secondary barrier and concludes it. On top of it, we set a whipstock. We talked about it early in the session a little bit, and we'll see if we can talk more about it, if we can go quickly through this presentation. There are different things that you need to be aware of, and these are typical, call it drilling related issues. As we will see in the whipstock assembly, we will orient the whipstock to go in a certain direction. It would be a disaster if it's a non-vertical area. You're setting it in, let's say that it's 20 degrees inclination, and you're setting it in the wrong direction. It means that you will kick off and you have to go all the way back to where you're supposed to go. So we orient the whipstock and then set it. And as we mill through, the milling of the window itself is quite fast. The problems come when you try to use a mill that is designed to cut steel, and you try to drill away formation with it. Very often you end up with, well, not very often, a lot of vendors would probably be insulted, but you could end up with something that looks like a Q-tip. Instead of a bit, if you see what I mean. It's packed of clay and so on, because it's not, if it's optimal for milling casing, it's not optimal for drilling formation, if you see what I mean. And if it's optimal for drilling formation, then it's not so optimal for milling the casing. So you can't have both. That's how it used to be back in the day. I'm pretty sure they have improved the tools and technologies, but still a valid problem. You need to also think about well control in these situations. You need to be able to circulate. You need to do in all steps many things to think about as a drilling engineer. One of the things you need to do, if you're a little bit, and this is the experience, if you are too eager and you start pushing on the mill, what happens is that when it goes out of the casing on the whipstock, it tends to go back. So you're milling along the old casing. And then, for one thing, you have a kick off, and then you have a return. So you create an S, which is very bad as a dog leg. It creates a fatigue point for the BHA, if you see what I mean. Yeah. So what you want to do is take your time and make this right. That's very important in this situation. Time is the essence here, not in so much spending as little as possible, but spending it right so that you don't get into trouble, because doing it fast may sometimes lead to problems and you need to take few steps back.
Okay, is not possible to save time to just put the what's the program is like a hanger and you put the cement block, then mix up and you just mill. What you need to cut the casing and move it's time consuming. You can just
Yeah, you need to establish a full cross barrier here according to NORSOC D10, right? And if you have a look back here, here at this point, the cement is down here. There's no cement on the outside here, and the log may not allow you if it's not allowed to use, call it formation shale collapse as integrity on the outside. You cannot just cement on the inside because there's nothing on the outside. You haven't the complete horizontal barrier. You remember one of the first slides that it had like a cross saying that the requirement is a full formation to formation barrier and in a certain extent. And that's what we have made here. This is why we had to do all these efforts. Very good question. Again.
because from the model borehole is already flood. We don't have any issues with because we have plugged from down. The premier barrel been plugged.
This is the
Yeah.
This is the primary and this is the secondary, right? And it needs to hold the same as this one. So you need the formation integrity here needs to be as strong as any initial pressure of this reservoir would yield, and at the same time you need the full cross section. Now it's a drawing here of the casing going into the it's not correct. It should be cut below here. Yeah, the drawing is incorrect. Yeah, so next step would be to just drill the 17.5-inch section. Once you have been able to kick off with the mill and you're outside the casing, you run a standard drilling assembly. It will not be a standard 17.5-inch section. There are a few things you need to consider. For example, you cannot use excessive forces as you have the BHA in the casing window. You may get stuck there. You can create a lot of swarf from the window if you start to have the pipe and tools, stabilizers going and working hard in the window. Yeah, high local dog leg. Yeah, so these are considerations. So be careful a little bit and monitor your parameters as you're drilling a section like this over a whipstock. You run your casing, you cement it, and that's pretty standard. And from now on, it's like a brand new well. You can forget about the sidetrack question. You drill your 12.25-inch, run your 958, cement it. And here we drilled a pilot hole. You guys know why we drilled pilot hole? A pilot hole is very often as vertical as possible to get the cross section of the reservoir, meaning TVD control, and then you know where to land out. You can plan your well, the main well at this stage. Again, balance plug, kicking off on the cement plug and landing out the well in the desired formation. If you have a difficult reservoir and you have a very specific sweet spot that you want to land out your well in, it's a known technique. Yeah. So an experience here is to wait until a cement is hard enough. If you have a cement that is softer than the formation, you're in trouble. It's quite hard to kick off. You would just follow the old hull and end up down in the pilot, right? Uh, and on Osgard, we did this all the time. The problem was that the cement never got as hard as the formation. The formation was harder than cement permanently, regardless of what you did. So it did what was called time drilling, and you have to kick off with a motor because it has a proper bend. So you use a motor with a decent bend and a special bit for it. So you point in one direction until you kind of um, yeah, dig on one side, on the side of the well, until you get the bit to sit on the wall. Yeah, go ahead.
You can't run a whipstock in a home.
Yes, you can. Yes, you can. You actually can do that. Yeah, we never did that though, but I know that Troll they did that. Troll oil, you know, the ones that drill 8 kilometer and longer wells with so many laterals. Yeah, they used to do that.
I have another question.
Yeah, go ahead.
And imagine the case you are drilling maybe a section, like maybe in the close to the reservoir, let's say 17 and a half in section, and you have a very long section.
Yeah.
And at some point you have maybe been stuck somewhere.
Yeah.
And we try everything we can, and we cannot release the string. And you need to sidetrack. You
Yeah.
need to, maybe you have to maybe release some parts of the drill string and try to sidetrack somewhere to
Yeah.
always follow the direction. Do you need to plug this one the same way you use here, like two barriers or just one barrier?
So your question is actually, if you drill like this and your drill string is stuck.
In the main borehole.
Yeah, yeah. Here.
Then you have a problem, and with the drill string, you have been stuck somewhere. We try everything to release the drill string, and we cannot. And we want to maybe release some of your drill string that we can and sidetrack.
Yeah, yeah. I would say that your question is quite open in a way. How are you stuck? That is my question. Are you? Is it a hole collapse? Let's say that the hole collapse is down here somewhere. Then you shoot off the string above, and then you cement a little bit and you sidetrack on it and you drill on. If the window is excellent, then you just keep on. You just cement back that part of the and you use your backup drilling BHA. Yeah, so that's what I do. The worst case scenario, as I see it, is that if you're stuck in the window, right? That means that you have to cut the pipe just above the whipstock. I would then cement back and place another whipstock above it. That has happened. That the casing exit is no good. So you need to set another whipstock. Yeah.
In that case, you have to plug all the section. I mean, all the section.
Yeah, everything here. Yeah. Yeah. You would always plan so that you have other possibilities above here to set another whipstock, at least one. Otherwise, you you have a very difficult scenario. Okay, so we kicked off on the cement plug, and we drilled the 8.5-inch section, and we installed the 7-inch 7-inch liner. We don't need this. We don't need these comments here. Yeah, yeah, okay. Cementing the liner, and we end up with something that actually looks like this, and this part is permanently abandoned. You have the cross section here. Again, the drawing is lying a little bit. It says that the casing goes into the shoe. It does not. What remains here is to run completion, perforate, and produce. Christmas tree and so on. The full production part. Part 3 of the presentation will be tools and techniques. Like we talked about, you need a whole lot of tools in order to cut the casing and do these different things. Here is a whipstock. This is a modern type. They didn't look like this when I was out. It didn't have this specific shape here. It would be part of the whipstock would just go narrower and narrower, and then it would be tied into a slot. So the mill would have a slot here where it would be bolted on the whipstock. That's the old-fashioned type, and I guess that would be the cheaper models still today. Whereas this is something that Baker showed me. The whipstock, you see that it has it goes like a wedge. It goes smaller and smaller. Kile. And it will be circular. If you look from the top and down on it, it's circular like this. Like this U shape. Yeah. So the mill, when you release it from the whipstock, you can start as it travels up here. It mills away the casing that it sits in, right? Yeah, I don't think we will go so much more into these details. At the bottom here, you have something that looks like a plug. It has an anchor, and some of them has a packer in addition, so that it has like a full integrity package at the bottom. Other ripstocks that we used to run had like a plunger in the bottom, like an activator, like this. It will be sitting down like so, and you run it down on a plug that you pre-install. So once you set the whipstock down, the activator would push up from the bottom, and it would set the slips on the whipstock. It's what we call bottom set. Yeah, activated from the bottom. Yeah, so this is the whipstock assembly. Here it is with the whatever is going on top. Here you have a flexible joint. You have you see this is the third mill. You have one in the front, one follow, and one window master watermelon mill. Is very often it's called the watermelon mill, the top one. You need 3 of them to be stiff enough, and typically what you do, you measure the OD of these mills as they are released. Let's say that you got the meters that you want. You want 5 meters out of the casing exit, and you have to measure. You measure on drill floor. Now I've set it, and the depth of the drill pipe, and you release it, and then you need to know the travel of the whipstock and then plus 5 meters, right? So then, okay, I got my 5 meters, I'm happy, but did I get the window right? So you measure the OD of the mills. If it's less than a certain OD, it means that you will get problems putting your drilling tools through there, right? And the casing also. So you need to mill until you know. So then you run again with another backup mill. And you'll find that, okay, the casing wore down my mills so much that I need to mill it larger. So, yeah.
So the milling tool is can it be enlarged, or you just find the size that's convenient for your window?
They are standardized, more or less. Yeah, they are standardized the sizes because if you're drilling, yeah, you need it to be so that it fits the 13 to 8-inch casing, for example, right? Um, yeah, you get that. And these things are standardized. What they are, I cannot really remember from the top of my head. But you will get this. These are experience based numbers, as I see. Here is a casing spare. This is quite cool. What you do um, is you see that this. What should we call this light green color? We call it light green. Magenta. No, it's not magenta. It's yeah, doesn't matter. If you actually that part here that looks like a saw edge or threaded or what it is actually threaded. That's what it is. So all this light green stuff travels on top of free to travel on the base. This whole thing on top travels on this base here. Um, what it means is that if you turn, for example, to the right, the green one would go down, and as it goes down, you see that it has to travel up and out. So the OD of the tool goes out, right? Imagine that you take the light green one and you push it down to the right. Then, because of the shape of it, these buttons that sits here, they will then start to dig into the casing, right? And if you pull from the top, then you will find that the harder you pull, the more stuck you get, because they will have to travel down the green ones, right? So that's the principle of a spear. And if you turn to the left, for example, it would release. Yeah. Set down weight and turn to the other side. So that's a principle for a spear. Yeah. So here we see a full string proposed by Baker. They call it mastodont. So many beautiful names, and it's quite cool because you remember. And this is a special combo for cutting, pulling, and jacking. And jacking means that you anchor up and you start hydraulically to jack, and you get tremendous forces. One presentation I saw, they do more than 850 tons of pull locally. Imagine that. Forces are extreme with the new tools. Yeah. So here is the anchor section, power section, spare. Yeah. Yeah, we're not going to talk too much about this either, because there are people who knows that a lot much better than me. But quite valuable, I think, for you guys would be this. Let me see if I can play this video for you guys. There we go. Ardine, if I'm not mistaken, that's the same as Weatherford, or they're part of Weatherford. So they set the plug, and now it's a balanced cement plug on top of it. Sponge ball is something that it's a proper sponge. You pump it through to just wipe the inside of the pipe free of cement. This is a package just to hang off the pipe. And here they are waiting for cement and suggesting other operations can be done. Sorry. Requirements to test the plug, dressing off and tagging the cement just to know that, yes, my cement plug is good. It's not contaminated and poor. Now we're getting into cutting. Yeah, I'll stop there. So it says marine swivel. Okay, that's very important. You see, you see the cutters here. They go out. When you have converted this into cutting mode, as you pump, there is an internal on the inside here. These knives, they go in towards the center of the pipe, and the harder you pump, the more they want to go out. All right. Um, Imagine if these cutters now are not in the same spot all the time, that they go up and down, like on a floating rig, right? That would not function very well, because instead of making a cut like this, you are actually just scratching the casing all over, and you may, if you're moving up and down, and you're partly through, you may break off the knives, right? So that's why we have what is called a marine swivel. In my days, a marine swivel was something that you placed inside the BOP, and the BOP closed some rams around it, and that held the string in place. Now, what they have here is a packer here to hold it in place, so that the knives can do their job undisturbed. I'm pretty sure that this technology, from the looks of it, would extend the life and precision of the knives. They would do a much better job than what they did before. Yeah. So that's a marine swivel, and you can do many cuts. Yeah. So now you do the circulation that we talked about. This is the way and the steps that you would do with the 13-8 inch casing that we cut and retrieved in the previous example. Only back in the day, you had to do this on many trips. You couldn't do all these different functions at the same time. So here is a spare. It retrieves the cut casing. Yeah. So I hope that gave you an idea. Here is a casing that has been punched, and that's different technology. We'll see how that works. That is to get proper circulation behind the casing. Here is section milling. Try to indicate the knives, they have to go all along the casing here, right? And section milling is traditionally used where the casing is stuck on the outside, and that would be most times in the open hole. And section milling would in itself create another problem, a lot of metal swarf. Yeah. Combination tools, this is a presentation of Archer and their barricade system. Try to speed things up a little bit. This is a very modern method. I guess many service providers would be able to do this, but this is special. This is modern. This is much faster than all the old section milling. It would totally replaces section milling, and you'll see why. Notice that there is no integrity here, right? So now we have perforated and we saw the casing, how it looks, right? On that picture earlier. You drop the guns down. You set that plug that we saw earlier. Yeah, so now you're flushing the inside and the outside of, uh, of the casing. Yeah. So now you're preparing the well for cementing. Typically, make sure there's no debris. Spacer for a cement job. This is the pump and pull method. Now you have created a cross section completely according to the regulations in both vertical and horizontal extent. Without pulling the casing, without section milling. Section milling, time consuming, and all the swarf is a huge problem. When there's a lot of this, yeah, it's sharp. You try to hold it with your hands, you cut yourself. They are like razor blades. I think that's it. Yeah. So other things to be concerned about. You guys know about the V0 and the V1 and V3 certification of plugs. It depends on what you're going to do for purpose. But if you want something that holds gas, you need it to be a V0, which of course is the extreme testing of the tools. There's a certain API standard for it. Here is a casing jack, like we talked about, pulling extreme force, and picture here of the metal swarf. It's a problem like you can't believe. Here, a little bit of section milling. You see a basket full of metal swarf. These are ditch magnets. They sit in front of you. You get a return from the riser, and then there's a flow line going in towards the shaker room, and then in front of the shakers there's like a huge ditch, and you put these magnets there to try not to get as much of it above the shakers, because imagine a shaker that has a mesh like this and all these fine threads sticking into it. You will never get it loose. You ruin the shaker screen, to put it like that. Yeah, you see it's like a mat. uh, yeah, so you ruin the shaker function as per se, but probably much more critical, this swarf will stay in the cavities of the BOP. And the BOP has rubbers that seals towards the drill pipe. Imagine that you're trying to seal, and you have a beard like this inside the cavities. You're not going to get a good test. We have seen that on some occasions, that it's quite impossible to well, the rubbers of the rams are completely eaten away, more or less. Not like they were brand new and then they just have to be replaced. Yeah. All right. Imagine that, 69 slides. And I took some of your break. I promised that I would ask you guys if you would like to have a, call it a Teams session with some of these vendors. They are ready to show you more, better animations, talk about the operations they've had, success stories, experiences, tools, how they work. If you guys want, I can set up, but it has to be outside the curriculum as per se. It won't be part of this lecture. So if you guys want, I will arrange a meeting. So yeah, I have all your emails, I think, so that I will just give that to specifically to Archer to begin with. I will also hear with the other ones, so that they can set up a time to meet with you guys. It will be like a Teams meeting that you can do on a volunteer basis. A lot of cool stuff and cool stories, I guess. Yeah. All right. 5 minutes before the time. I'm I'm shocked. 69 slides. All right, I will do that then, since the feedback is positive. Any questions now at the end? No, I think that you guys would have to agree. Typically, I'd say just next week. And let's just try to say a time that is good for you guys, and I can start to propose that already, and we'll see if that works for you and them. Wednesday, for example, after lunch. How anybody has a lecture or something?
I have a mandatory expert in Teams mindset from 9 to 4.
9 to 4. Okay, so Tuesday then.
Rather that is
What time?
After lunch, Tuesday.
The lecture is
drilling
this class.
from 12 to 2.
Yeah, Monday then, after lunch.
Yes. From next week, so it doesn't matter.
Okay.
Why not Friday?
Yeah, why not?
This Friday.
Friday is not a good day in the industry. Everybody has the handover and they're preparing the weekends and so on. So, I know Friday is not very good. Let's say Monday, either the first coming or the next one after lunch, as a proposal. All right?
Next Monday, right?
Yeah. Yeah, I'll drop an email with this as a proposal. We'll see. All right. Thank you guys again.